Good morning. This is Professor Gardetto, and I'm going to be talking a little bit about your last homework assignment of week 4, homework 12. Um, I did build the midterm this morning, and so I'll be talking more about the midterm in tomorrow's live lecture. Today's Wednesday, um, July 7th. Um, so I will be recording tomorrow's live lecture as well. So you make sure you watch that recording before attempting the midterm. Homework 12 is coming up here. And before I start homework 12 is going to be some heavy lifting for a lot of you that are a little bit uh, unsure of what to do when you add fractions that have different denominators. So, because the fractions that we look at in Math G are called rational expressions. So, I just want to take a little time and talk about what happens when we have different denominators. Okay, so if we have the same denominator, okay, if you have two fractions that have the same denominator, you guys know a half plus a half is a whole. Half a half, half plus a half is a whole, right? But the way we mechanically do this, if we have the same denominator, we just write that denominator one time. In fractions, we only could add fractions that are the same, right? So 1/2 plus 1/2, we can just add the ones together, and then we get a whole, right? We get a whole. If we had 1/8, right? 1/8 plus 3/8, right? We have 1/8 plus 3/8. Those are the same type of fraction because they're both eighths. And so we say this is just 4/8. And then we have to reduce 4/8 to lower numbers. And we do that just by simplifying that fraction. Okay, so as long as the fraction has the same denominator, it's no problem. Now, when the fraction has different denominators, we need to find something called a common denominator. And so I usually just write one fraction, but I'll just go ahead and write 2 for right now. And we're going to find a common denominator by finding what the least common multiple, not greatest common factor, but least common multiple of these two numbers are. So if we count by twos, multiples of 2, 2, 4, 6, 8. 3, if we count by threes, 3, 6, 9, 12. Well, what number do we get to first? 2, 4, 6, 3, 6. So we get to 6, which just so happens to be 2 times 3. And that's just a coincidence. We don't always multiply these two numbers together. But last resort, if we can't find any common multiples, we multiply these numbers together and we get a common multiple, but sometimes it's not the least common multiple. So notice the denominators changed. If the denominators change, the numerators change. Let me say that again. If the denominators change, the numerators change. So now, to find out what the numerator changes to, what we need to do is find some equivalent fraction. So what's the equivalent fraction that has a 6 on the bottom that's equal to 1/2? Well, if this number is multiplied by 3 to get 6, then this number has to be multiplied by 3. And we get 3 over 6. And 3 over 6 is equal to 1 over 2. So we're really not changing the value of the fraction. We're changing what the fraction looks like. Do the same thing with 1/3. 1/3, 2 times 3 is 6. So 3 times 2 is 6. So if we multiply by 2 on the bottom, we multiply by 2 on the top. And now we have the common denominator, 6, and we just add the numerators together. And we get 5 over 6. So this is the concept that we're going to be talking about in homework 12. It's just that the fractions are rational expressions. So let me clear my screen here, and let's look at some problems. Okay, there's 20 problems, And the first few have you add fractions, and they have the same denominator. And so these are the light lifting. The heavy lifting comes towards the end. So let's say we had this problem. This problem is number 2. So if we have the same denominator, we just write that denominator one time, 5x cubed, and we just add the numerators together. 6 plus 9 is 15. Now, we do have to simplify the fraction. So we simplify it just by seeing if there's anything that cancels, and 5 goes into 15. So 5 cancels, the 15 cancels and makes a 3. So we have a 3 left over on top because 5 went into 15 3 times. And we have an x cubed on the bottom. And we're going to probably see when we click here, we'll see those boxes. Yeah, so we're going to put those boxes, and there's your little exponent button too. So I won't put that in there. You guys are pretty good at doing that by now. Okay, so that's problem 2. I also wanted to go over problem 3. Let's see why I wanted to go over 3. Okay, all right, so 3 looks a lot longer, but good thing is the denominators are the same. The denominators are the same. So as long as the denominators are the same, we can just write that denominator. Sorry for the squiggly line because I'm using a mouse. So let me write it out. 3x plus 2. You're going to want to have a pencil and paper when you're doing this assignment. X minus 6 is the denominator. It's the same. So what I say about the denominators, if they're the same, we can just add or subtract the numerators. In this case, we have to be careful because we don't see parentheses. I'm going to put these in parentheses. And the reason why I got to put them in parentheses is that minus right there, that minus is going to affect the 5x, and it's also going to affect this negative 8. So 7x minus 5x is 2x. And then negative 1 minus negative 8. Let me write this over here. Negative 1 minus negative 8 is really like negative 1 plus a positive 8. Remember, if we have a minus minus, it becomes a plus. So negative 1 plus 8 is, negative 1 plus 8 is 7. So it's 2x plus 7. And we can leave the answer in parentheses here, or we can just leave it as 2x plus 7. If it's being multiplied by something else, you need 2 sets of parentheses. But now we just make sure we can't simplify this. I don't see any other 2x plus 7s down here, so we would write that as our answer. Okay. Let me clear my screen and go to problem number 5. So problem number 5 talks about equivalent fractions, making equivalent fractions. So if the denominator changes, remember I said the denominator changes, the numerator has to change. So here we have the denominator definitely changes. We have a 4s, and then here we have a 16s squared t. So you need to think about what you have to multiply 4s by. What do we multiply 4s by? What do we multiply 4s by to get 16s squared t? Well, let's look at the numbers first. What do we multiply 4 by to get 16? Well, we have to multiply 4 by another 4. What do we multiply s by to get s squared? Well, we have to multiply by another s. And then we don't have any t's over here, but we have a t over here, so we have to multiply by a t. So let's double check that. 4s times 4st is 16s squared t. So if you multiply by 4st on the bottom, guess what we have to multiply on the top? In order to have an equivalent fraction, you have to multiply by the same thing on top and bottom. So, and that keeps the fraction equivalent. So we have to multiply by 4st. So in that box, that's supposed to be a t right there. in this box here is 4 times 6. So in this box, you would put 24. That's 4 times 6. And then you would just put the ST next to it. So 24 ST. So we're creating an equivalent fraction. And that's really important for these heavy lifting problems because these are going to have different denominators. Okay. Number 8 is the next one I want to go over. I think it's going to have you create an equivalent fraction again. Okay. So let's look at the denominator, 2t minus 7. I don't even worry about looking at the 4t right now. I'm just looking at the denominator, 2t minus 7. And then over here we have a 2t minus 7, but we also have this t minus 8. So this top number needs to be multiplied by the same thing that this is multiplied by. And this 2t minus 7 is multiplied by a t minus 8. So in this box here is 4t times t minus 8. Now, I'm not sure if you can leave it like this or you have to multiply it out. So I'm going to test this program out here. See if you can go 4t and then parentheses. Shift 4t parentheses. It's not using my parentheses, so looks like we might have to multiply it out. So 4t squared, 4t times t is 4t squared. So I'm going to use this exponent, 4t squared. Okay, and then minus 32t. So I multiplied this out, 4t times t minus 8, because it wasn't letting me put parentheses in there. Let me see if I check my answer. This should give me a green check mark here. There we go. Okay, so make sure you multiply these out. And unless you can find a way of putting the parentheses in there, but I went ahead and multiplied it out. Clear my screen. Okay, let's go over number 9. Okay, all right, number 9, again, creating equivalent fractions. So we have an x plus 9 here, and then we have this trinomial here that looks like it is factorable. If you have a trinomial and it looks factorable, I would try to factor it. So let's see. We have an x squared, so I know it's going to be an x and an x. And this one's a straight diamond problem with negative 27 on the top and positive 6 on the bottom. So there should be numbers that multiply to get a negative 27. One's got to be positive, one's got to be negative. So I put a negative and a positive. And they have to multiply to get negative 27 and add to get 6. So when I think 27, I think first two numbers popping in my head are 3 and 9. So and those would work if you put a negative 3 and a positive 9. You got to make sure the 3 is negative. The 3 is negative, and the 9 is positive. You need to factor to see what you have to multiply by, because now we have an x plus 9 here, and we have an x plus 9 here. So all we need to multiply this by is the x minus 3. So that's exactly what this x is multiplied by. This x has to be multiplied by an x minus 3. Remember, if the denominator changes, the numerator changes. So this has got to be x times x minus 3. So x times x minus 3 is x squared minus 3x. x squared minus 3x. That's what goes in this box right here. Okay, so difference on number 9 is you actually had to do some factoring. Okay, I'm going to skip to number 11. And here's where the heavy lifting starts. Heavy lifting starts here because your fractions have different denominators. So if they have different denominators, we need to find a common denominator. So just like I did that one before we started, like 1/2 plus 1/3, and I found 6. That 6 was the common denominator. In this case, we have a 7, and then we have some x's and y's. So I'm going to write the common denominator one time, but I'm going to just make this line a little bit bigger. So, so between 7 and 21, okay, 7 and 21, what's the smallest number that 7 and 21 go into? If you count by sevens, you would get to 21, right? Because 7 times 3 is 21. So 21 is a common multiple of 7. Actually, it's the least common multiple is 21. So notice we do not multiply 7 times 21. That'd be a huge number. So it's the least common multiple. For the variables, we have x squared here and we have x here. All right, I'm going to say something very, very important right now. So if you're looking away from your screen and just listening to me, you always take the highest exponent. You always take the highest exponent in your variables in your denominators. So we have x squared here and we have x here. So x squared is higher. Okay. Might want to write yourself a note. Highest exponent. If it's a tie, y and y, we just take a y. Okay. If we didn't see a y here and we see a y over here, then we'd still have to take a y. It's always the highest exponent. Okay. Now, the reason why you did these problems here before, like 7, 8, 9, and 10, is that now you have to find equivalent fractions. Equivalent fractions. So what does this need to be multiplied by? What's 7x squared y need to be multiplied by to get 21x squared y? Well, just simply a 3. That's the only thing you have to multiply that by is a 3. So you have to multiply the top by a 3. Well, we can do that multiplication right now. 3 times 3 is 9. So we put a 9 there. And this is a minus, so I'm going to put a minus here. And now we look at the denominator here, 21xy. What do we multiply 21xy by to get 21x squared y? Well, you just have to multiply that 21xy by an x. So we multiply that 1 by an x. And there's no simplifying we can do here. 9 minus x over 21x squared y is simplified. You just want to see if you can factor anything or cancel anything. We can't do anything. Okay. All right, that was 11. I'm going to go to a couple more problems, and then I will be done here with this mini video. Doing way more problems during lecture today. So you might want to view that lecture or attend it live at 9 a.m. All right, so this problem is 16. Now notice these denominators are binomials. If you have a plus sign or a minus sign in the bottom, it's a binomial. You want to look to see if you can factor any of the binomials first. So in this case, 3y plus 15 is factorable. Y plus 5 is not factorable, but 3y plus 15 is factorable. And if it's factorable, you're going to factor it. Okay, that's the whole reason why we learned factoring last week. So I'm going to take out a 3, which is the greatest common factor, and I have y plus 5. That's the first denominator. So now I'm going to rewrite this 2 fractions into 1 fraction, and I'm going to use the least common denominator. So we have 3 times y plus 5. Well, over here I have the y plus 5. I just don't have the 3. So I need to have a 3. And then I just need to have a y plus 5. I need to have a y plus 5. So I'm using that exact denominator here. 3 times y plus 5 is exactly what I have in this first fraction. So that top 4y minus 7 does not change. 4y minus 7, I'm just going to put it in parentheses because you might make a mistake with this minus sign. So I'm going to put the minus sign here. And then this y plus 5 gets multiplied by a 3. So this y minus 4 has to be multiplied by a 3. Now I'm going to make sure I put this in parentheses. 3 times y is 3y. And 3 times negative 4 is negative 12. Okay, so make sure you write your fraction bar long enough that you can put all this stuff on top. Okay, not done yet because we say we need to simplify. So simplify just means to write it a little bit shorter. We have some like terms that we can combine up here. So let's see, 4y minus 3y is y. And be careful with the negatives. We have negative 7. We have negative 7 minus a negative 12. Remember, minus makes this a plus and a plus. So negative 7 plus a positive 12. Negative 7 plus 12. Negative 7 plus 12 is, well, negative 7 plus 12 is 5. So the whole top, the numerator, reduces to y plus 5. Now, if I want to leave that in parentheses, I can, or I can just leave it as y plus 5. But look what's on the bottom. This is done on purpose, by the way. Okay, this is done on purpose. There's a y plus 5 on the bottom. There's a y plus 5 on the bottom. There's a y plus 5 on the top. Those look the same. I'm going to cancel them. Now, don't think the answer is 3. I mean, you're almost there. Don't think the answer is 3. If everything cancels on the top, you got to put something. We just put the number 1. So that's 1 over 3. That's what we put in the box right here. Okay. Okay, last problem. Number 17. Number 17. All right, 17 has, okay, again, it has denominators that are binomials, but these binomials are not factorable. However, these binomials are opposites of each other. They're reverse subtraction problems. If you reverse something and then subtract them, you get the opposite, right? You get the opposite. Doesn't matter what the numbers are. 3 minus 2 is the opposite of 2 minus 3. So when you have opposites, it's actually a little bit easier. Okay? You get to choose whatever one you want to make your common denominator. I'm just going to choose the b minus 8. Okay? B minus 8. So I'm going to use b minus 8 as my common denominator. Now, if I use b minus 8, I do not have to change the b minus 10. So I'm just going to write b minus 10 there. I'm going to leave it in parentheses. Okay, always leave binomials in parentheses. If you want to leave this in parentheses, you can, but it really doesn't matter. But this one matters because there's a minus there. Okay, so now here's a question. What do we multiply 8 minus b by to get b minus 8? Well, notice the 8 is positive here, and the 8 is negative here. And the b is negative here, but the b is positive here. So how do we change negatives to positives? We multiply by negative 1. we multiply this by -1, and it changes to -8, which is right there, and positive b, which is right there. So we need to multiply that top by a -1. So I'm going to put in parentheses. -1 times b is -b, and -1 times 10 is -10. Okay, again, try to make this line long so you can put a whole bunch of stuff up on top. Okay, now we have to combine like terms. So we have a b, and we have a minus, and we have a minus again. So b minus a minus b is like b plus b. If you want to, let me change colors here. If you want to, when you see a minus here, you can go plus, and then you can change both these signs to a plus. And then you don't have to, you wouldn't make a mistake with the negatives, I don't think, because you're going to see b plus a positive b, and you're going to know that's 2b. So 2b, and then minus 10 plus a positive 10. Well, -10 plus a positive 10 cancel. So we don't have to put 0. So all we have left on top is 2b, and on the bottom we have b minus 8. And then can this be simplified any further? Can I cancel that 2 and that 8? Nope, can't do that because that of attachment there, that b minus 8, these are attached. We only can cancel a b minus 8 with another b minus 8. So we'd write this as our answer. Okay. So a lot more problems coming up on the live lecture today. And then tomorrow you'll have another live lecture that will be recorded. If you can attend it live, that'd be great. I'm going to be talking about the midterm. And the midterm will be, it's actually on Connect Math now, but it'll be available Thursday through Sunday. 2 attempts, and I'll be talking about that more tomorrow. Okay? Have a good day. Bye.